This video will cover the topic, Identifying Polynomial Functions.
What is a polynomial?
A polynomial is a monomial, or the sum or difference of many monomials. We call each monomial a term of the polynomial, and we can only add or subtract the terms in a polynomial. A polynomial function with one variable x is a function that can be written as follows, where the coefficients a sub n minus 1, and so on, are real numbers and the exponent degree n is a whole number. The degree of a polynomial is the highest degree exponent of its terms. For example, let's look at the polynomial 4x cubed plus 2x squared plus x plus 2. What is the degree of this polynomial?
Is it 3 because of the 4x to the third term?
Exactly. The highest degree n of the polynomial is 3, so this is a degree 3 polynomial. Now let's learn how to identify what is a polynomial function and what is not a polynomial function. When trying to identify a polynomial, we look at the coefficients to see if they are real numbers, and the exponents to see if they are whole numbers. Let's do a few examples identifying a polynomial function. V of x equals 8x to the 9th plus 0.6x to the 5th. This is a polynomial function. The coefficients of each term are real numbers, and the exponent values n are 9 and 5, which are both whole numbers. Another example. F of x equals 6x cubed plus 5x minus 2 times the square root of x. This is not a polynomial function because the last term, negative 2 times the square root of x, is equivalent to negative 2 times x to the 1/2. Since 1/2, the degree of the exponent, is not a whole number, we know that this is not a polynomial function. A third example, g of x equals 1 over x to the 7th. This is not a polynomial function either. When we are trying to identify polynomial functions, we do not leave variables in the denominator. So when we bring the term x to the 7th to the numerator, it becomes x to the negative 7. The exponent value negative 7, as we can see, is not a whole number. So whenever there are variables in the denominator with positive exponent values, we know the function is not a polynomial function. And one final example, is h of x equals negative 2 a polynomial function?
This is a polynomial function because the coefficient is a real number.
Yes, a polynomial does not have to have both a coefficient and a variable in every term. It can have either or. So even though this term does not have a variable, it is still a polynomial function.
So when identifying whether a function is a polynomial function or not, we should look at each term individually, bring any variables in the denominator of that term to the numerator, and make sure in every term that the coefficients are real numbers and the exponents are whole numbers.
You got it!